Lecture 47 is now looking at our 422, which um, has actually only one extender that produces a new space point group, and that is the horizontal mirror plane. But before I do that, I just want to remind you, because some of these higher indices, like these 422s, 3223, we had simple objects to make you recall what they were based on. And so remember, this is one where we have a square at the top, and then we have twofold axes. Right, so up here is the square, and then we had shown that basically if I look out here as usual, and then I have also 90 degrees to this one, but it comes out one of the edges here. So again, if I were to look down on this crystallographically, I'm looking down here, so my eye again is looking down this way. Then I would see this fourfold axis, and when I look to the left, I would see twofold axis because it's passing through, the middle here. But I would see the same thing coming out of this side here. So I would see, twofold axes passing through the sphere this way. But I would also see them coming at 45 degrees because of this one that's coming out the edge. So I would see a lot of twofold axes. Like that. And that's, our 422 symmetry-wise. Now, for the motif, this means that, again, let me just draw the symmetry about this point here. Two axes to help me draw. So again, those are, well, I guess they're twofold axes, but they're really just there to help me draw. And so that is the motif for the 422. Remember, there's no extra symmetry elements. These are just axial combinations. So you see a fourfold axis here, but the twofolds relate these things to each other, and you don't have any other symmetry. But of course, now we're going to add the horizontal plane, and you know what that's going to do. We've done this many times before, and you can see it very clearly here. If I add this horizontal plane, it's going to produce the same kind of bullseye structures in each place because it's just reflecting from front to back that we've seen all along here. And of course, when you recognize that, that tells you it's producing mirror planes now along the twofold axes in this direction. It also tells you it's producing mirror planes along the other twofold axis in the other direction. Right, so all of a sudden we end up with mirror planes everywhere. Now, of course, we already learned that the fourfold axis has a subgroup of a twofold, and these are all twofolds, and they all have perpendicular mirror planes. So using our theorem, we know that there's going to be an inversion center in here, but in this particular case, it doesn't really matter because all the elements are related to each other without really needing to know that. I mean, we know that because of our previous, that these, remember we said A pi is buried in a lot of things, and here's another example. We have a horizontal mirror plane, and we know we're going to have an inversion center. But in this particular case, the inversion center actually doesn't relate all the elements in a unique way, and is not really necessary to describe the group, even though it is there. And for that reason, this is called, like the other ones we had, this is called a 4M, right? Because we have mirror plane perpendicular to the fourfold, and we have two two folds that are unique. And you can tell from looking at the motifs. So this is 4 over m, 2 over m, 2 over m. Okay. So that is a unique new one that is produced. The other three do not produce anything unique, and you can see that here. Here's our 422. Our 422 that we just looked at. And we just produced this one. The other ones don't produce anything either unique or crystallographic.